Buenos días a todos. Good morning, everybody. I'm presenting this morning on Site 37. And, you know, it was very nostalgic for me this morning when I was sort of thinking about this. 20-something years ago, I was in this river valley with Professor Simon Mitchell, collecting rudists and being fascinated by this section. Who would have thought that this would be the outcome? So when this opportunity came up, I asked him if I could put something together, and without a doubt, here we are. So thanks very much for sharing in this moment with me. So it's the most and thickest limestone succession with abundant rudist bivalves within the Caribbean faunal province. And this is being presented along with my co-author and colleague, Professor Simon Mitchell, who is the rudist expert in Jamaica at the moment. So for those of us who are not sure where Jamaica is, we are in the Central Caribbean, and the site under study is in Clarendon Parish in the center of Jamaica, and it's to the north in Clarendon. A very rural location. In this particular slide, I'm just going to point out to you, this is the central inlier, and the site under study is present in the central inlier. What we have here are the three main blocks or belts within Jamaica. This is the Blue Mountain block, this is the Clarendon block, and this is the Hanover block. And the deposits that we're talking about has an extension that takes us into the deposits over in Western Jamaica here. And generally, Jamaica consists largely of about 34, 35 inliers. We're still counting because we're still doing research. And the largest of these inliers is the central inlier. And it provides us with a snapshot of the evolution of Jamaica and how things actually work. This is the second largest inlier. It runs second to the Blue and John Crow Mountain inlier. And if you just walk with me a little bit, you will see that within the island itself, our interior tends to contain most of our older rocks, and we are surrounded by about 70% white limestone. So just to point out a little bit, this is the formation that my deposits are in. This is the Guinea Corn Formation, and you'll see that it sort of interfingers, but this is the shoreline, going that towards the east. But towards the west, it thickens into the basin and continues into Western Jamaica, as I tried to demonstrate on the map before. There are a series of shales, and these shales actually they pinch out or thin out towards the shoreline. So the shales are sort of doing something opposite to what the limestones are doing. And it's a transgressive regressive sequence. And what has happened is that we have about 32 cycles within this sequence. And these cycles are on meter and tens of meter scale. And it is within these deposits that we're finding the rudist-bearing limestones, which are quite diverse and quite interesting. And down here, we're seeing the Guinea Corn section. And this is a simplified log. For how many hours I've spent logging this thing with Professor Mitchell, I can tell you that this is very, very simplified. And of course, this is his recent map of the central inlier. And just to point out, that this blue area here, all of this blue material, represents the Guinea Corn Formation. So I mentioned rudists, and for those of you who don't know what rudists are, these are a group of filter-feeding bivalves. They're mollusks. They lived throughout the late Jurassic into the Cretaceous, and they were the main carbon-producing organisms on the Cretaceous carbonate platforms before they died out with the end Cretaceous extinction. And of course, rude just means that they're rough, although the pictures of them might tell you a different story. Rudists occur in this particular deposit, or at least in this sequence, in growth position. Some of them are toppled over. Some of them are transported within the shales. So we have fragments, and we have them with benthic foraminifers. And what we also find is that the rudists and the forams also give us quite a bit of zonation within the Jamaican scenario and can extend throughout the Americas. So without having to go through all of this, I just want to point out that we have some inoceramids. We have a very large one. Well, I'm in Jamaica, so large for us is maybe not as large as this region, but certainly we have a 30 centimeter large inoceramid. I have to keep repairing Professor Mitchell's air conditioning unit because he keeps the room very cold for this one sample. So we have in the guinea corn, as I mentioned, these cycles. And it is thought that these cycles are on Milankovitch cycles, and we are seeing this cyclicality throughout about 32 cycles throughout the whole system. And it extends into inliers to the west in the Hanover block. These are just a couple of pictures, so the slides look a little interesting after all of those words. But here we have fragments and whole tests of some rudists, and these are in some of our tidal flat mudstones. Over here we have, these are corals, bits and pieces of rudists, and it passes directly into these rudist-bearing limestones. I think I can show you something nicer. And these are rudists. And yes, they look maybe rude, I don't know. Meaning rough. This is Chypocella, which is very, very popular. The abundance in the locality is very, very high. And I don't know if you can see well, but there were like elevators, and this is the second valve. The top valve is pretty small, and this is a cross-section into one where you can see the teeth and ligaments. You can see the top valve on this one as well. We also have smaller radiolitids. You can see in this one here, that's the second valve, and the larger piece is the bottom valve. And again, these were just sitting on the seafloor, having a good time. Praebarretia is also another one, but I ran out of the number of slides, so I couldn't add any more. But this one is very interesting. This is Titanosarcolytes giganteus. This is only found in the Americas. And so far, this one is quite big, but we have another sample from the Marchmont inlier that is just over a meter in length. And it essentially just sat on the seafloor and filter fed. And it's the largest, the one we have found in Jamaica, including this particular specimen embedded in this rock, is the largest ones yet found in the world. So I think we can boast that a little bit. This particular specimen is of particular interest because this is the specimen that started the study of rudists in Jamaica. This is Macgylavria nicolasi. This is what the top of the valve looks like. And this is the bottom valve, this is the top valve, and if you take it apart, this is what you see on either side. So here we have more of these guys. This one is toppled over, and the other two, they are in growth position. You can see some more over here in growth position. Then there is some rubble, and if you search through, you can see pieces of Chypocella and other rudists sitting in there. And then we have these forams, Orbitoides, for example, Chobina. This is a cross-section of Orbitoides, and we have Vaughnia. And this is very, very significant here, Whitfield 1897. And when I get to the tradition, you will appreciate exactly how all of this came into being. So, many, many moons ago, the people in this particular area wanted transportation routes. So they wanted roads to get to markets, because this place, even now, it's still pretty remote. And so they asked the local political authority to build them a road. So there's this guy called Deeth, and he's the chief engineer, and he's following through with his road building, and he comes upon the sample of Macgylavria. He didn't know what it was, but it was fascinating, so he collected it, brought it to Kingston, and took it to somebody named Nicholas at the Institute of Jamaica. Nicholas then introduced the specimens to Dwyer, who then introduced the specimens to Hill, and they both sent a whole pile of stuff to American Museum of Natural History back in 1897, when Whitfield decided to describe and name the specimen. So that specimen a while ago is actually present in the Geology Museum, and it was the first one that was found that actually started all of this work. So since then, a lot has happened. We've had monographs that have dealt with the Rudists of the Americas. Chubb has actually put together a full monograph documenting the material from the Guinea corn, from the Peters Hill and Peters Rock Formation, and he has also managed to do several specimens across Cuba, Mexico, and Puerto Rico, and parts of America, the United States of America. So where we are now, these are my geology rock stars. So the only one I left out was Treckman. He did a monograph on Prae-Barrettia and Barrettia in 1922 and 1924, respectively. We have also Ted Robinson, who worked along with Chubb and Tony Coates back in the day to look into Arthur's Seat Formation and other Cretaceous material across Jamaica, as they were heavily involved in the then Geological Survey. And then this is Simon Mitchell, the current Rudist expert in the island, and he has put together more than 20 publications. I decided to stop counting. I can't get through them all. But the reason we wanted this site to be recognized is because we have different Rudist assemblages. Basically, our Rudists in the Americas are endemic. They are different from the old world Rudists you find in Europe. The exposures are spectacular. They show abundance and diversity. They are the most studied within the region, and that would include Mexico, US, Canada, and Puerto Rico. The succession itself tells you about the sea level cycles as well as transgressive regressive systems within the Cretaceous of Jamaica and parts of the development of the Caribbean plate. And of course, the assemblages are also quite spectacular for a carbonate platform. So, with that, I say goodbye with Titanosarcolytes. Thank you.
Thank you. Thank you so much for this brilliant presentation.